This is a review of some of the sections for chapter 1 in preparation for the exam. Okay, 1.178, we talked about it earlier. F(x) is 1 plus 3x cubed minus x to the fifth. It's asking is the function is even, odd, or neither. So what you do is replace x with negative x. F of negative x is 1 plus 3 negative x cubed minus negative x to the fifth. That's 1 minus 3x cubed plus x to the fifth. It's not the same as the original. It's not the opposite of the original either. The opposite of the original is negative of that, which is negative 1 minus 3x cubed plus x to the fifth. These are not the same. So the answer is neither. 1.157, the perimeter is given to be 20 meters. Okay, so if we call them x and y, well, perimeter is 20 is 2x plus 2y. Subtract 2x, 20 minus 2x is 2y, divide by 2, y equals 10 minus x. So the area function is x times y, it's x times 10 minus x, or 10x minus x squared. Okay, the domain of the function d is parenthesis 0 comma 10 parenthesis. Okay, x is not allowed to be 0. It can't be 10 because that would force y to be 0, and it can't go past 10. So the domain is 0 to 10 like so. 1.541 looks like this. 1/3 ln x plus 2 cubed plus 1/2 of all this mess. The 1/3 can climb up, and when it does that, they cancel out. The 1/2 can climb up. It climbs up over here and climbs up over here. 1/2 times 2 is 1, so these guys cancel out. So I'm left with ln x plus 2 plus ln x to the half minus ln of x squared plus 3x plus 2. That means square root. Put them together, ln x plus 2 times x to the half means square root of x. Minus means divided by x squared plus 3x plus 2. Furthermore, I can factor this into x plus 2, x plus 1. These will cancel out. So final answer is ln of radical x over x plus 1. 1.2, number 17. Here's 1.572, but we already did that. Okay, 1.217, you're told at 70 degrees Fahrenheit, you have 113 charts per minute. 80 degrees Fahrenheit, 173 charts per minute. So let t be a function of n, which is y equals f of x. T is temperature, n is the number of charts per minute. So my ordered pairs are 113, 70, x, y, and 173, 80, x, y. Slope is y2 minus y1 divided by x2 minus x1. 10 over 60, 1/6. Plug in y minus 70, y minus y1 equals m times x minus x1. Clean it up. Y equals 1/6 x plus 307 over 6. Change y and x to t and n. So t equals 1/6 n plus 307 over 6. Slope is 1/6, which means for each change of 1 degree, we increase the chirping by 6 chirps per minute. 1.419b asks for the domain of f of x equals 1 plus x over e to the cosine x. Well, the only trouble spot would be when the denominator is 0. So when is e to the cosine x equals 0? Well, e to anything is never 0. E to the x is always positive. So the domain is all real numbers. I'm not going to have any trouble with plugging in anything. 1.3, 42, f of x is radical x minus 3, g of x is x squared, h of x is x cubed plus 2, or maybe that's 41, sorry. Anyway, f circle g circle h, f of g of h of x, f of g of x cubed plus 2, and that goes in for g, which means I square it, so f of x cubed plus 2 squared, and then this thing goes in for f, which is radical, this thing behind my finger, minus 3, so square root of x cubed plus 2 squared minus 3. Okay, we already did this one. 63a, inverse cosine of -1, call it theta. Cosine of theta is -1. Cosine of 180 degrees are pi radians. All these problems we're supposed to do in radians, so theta is equal to pi. Let's see. 37c, f of x That's f of x plus 1 over x. And now this whole mess goes right here and there. So it's x plus 1 over x plus 1 over x plus 1 over x. Multiply top and bottom by x here. So x plus 1 over x plus x over x squared plus 1. Domain is all real numbers except for 0. 0 is not allowed here. Okay, and let's see. 1.5, number 70. Okay, we've already looked at that. The tangent of inverse sine of x. Okay, so here was the outline, but you can look back at a previous video on how we did that. Call this theta. Sine of theta is x over 1. Do my SOHCAHTOA. So the picture is theta, opposite, hypotenuse. Adjacent comes out to be this. So tangent of theta is x over radical 1 minus x squared. 37b, log base 8 of 60 minus log base 8 of 3 minus log base 8 of 5. So it's log base 8 of 60 divided by 3 times 5, 60 over 15. It's log base 8 of 4. Call it x. 8 to the x power is 4. Change this to base 2. Change this to base 2. 2 cubed to the x equals 2 squared. 2 to the 3x equals 2 squared. So 3x equals 2. X equals 2/3. Okay. And 41 we already did. 53b, ln of x plus ln of x minus 1 equals 1. I'm allowed to multiply these. So ln of x times x minus 1 equals 1. Exponentiate to get rid of the ln. So that gives me x squared minus x is equal to e. X squared minus x minus e equals 0. Do my quadratic formula. X is negative b plus or minus the square root of b squared, 1 minus 4 times a times c, negative e, over 2 times a. 1 plus or minus radical 1 plus 4e over 2. I get rid of the minus because that would give me a negative. And in the original problem, I'm not allowed to take that ln of a negative. So the only answer is 1 plus square root of 1 plus 4e over 2. 1.2, number 5, asks for the domain of cosine x over 1 minus sine x. I solve 1 minus sine x is 0. That means sine of x is 1. Theta is 90 degrees or pi over 2 or a multiple of 2 pi beyond that. So theta is pi over 2 plus 2k pi, where k is an integer. And that's what I get thrown out of my domain. So the domain is all real numbers minus a set consisting of pi over 2 plus 2k pi. K is an integer. Okay, 1.571 we've already tackled. The 1.135, h of x is this thing. Okay, I have a fourth root, so I can only take the fourth root of non-negatives, and the fact that it's in the denominator means it has to be greater than 0. So x squared minus 5x greater than 0. Factor x times x minus 5 is greater than 0. That gives me x equals 0 or 5. 0 and 5 are not included in my solution set because that gives me a 0 in the denominator. Open circle, open circle. Do a sign chart. Plug in negative 1, 1, and 6 in regions 1, 2, and 3. Negative 1 gives me a negative times a negative, which is positive. Positive greater than 0 is true. Shade that in. Plug in 1. 1 is positive. 1 minus 5 is negative. So the product is negative. Negative greater than 0. No, that's false. Don't shade this in. Region 3, plug in 6. 6 times 6 minus 5, positive, 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 true. So the domain is negative infinity to 0, parenthesis, union, parenthesis, 5, comma, infinity. 49, f of x is absolute value of x. Absolute value of x is less than or equal to 1. That means x is between negative 1 and 1. I have the absolute value function. But for x, absolute value of x greater than 1, which means x is less than negative 1, or x is greater than 1, it's the constant function 1. So this is what that function looks like. 57, 63, the volume of a box. Okay, so this is 12, this is 20, cut, 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 x. So cut out the flaps and fold. I lost 2x in both dimensions, x here, and x here, and x here. So it's going to be 20 minus 2x times 12 minus 2x times x. So that's an expression for the volume. Okay, 7a, slope is 2. So I'm just changing the b, y equals 2x plus b, where slope is 2. So here are some representative samples of those. Part b, f of 2 equals 1. That means the graphs all go through 2, 1, and I just change the slope. So y minus 1 equals m times x minus 2. A little bit of touch up, y equals mx minus 2m plus 1. What do some of them look like? No, just have a bunch of lines that pass through 2, 1. C, which belongs to both of them, well, y equals 2x minus 3. Okay, so we want the slope to be 2. So y equals 2x minus 3, put a 2 there, and that comes out to be that. See 1.337b, G circle F. Here's F, here's G. So G of f of x is G of all this mess, and this mess goes here and here. So x plus 1 over x plus 1 divided by x plus 1 over x plus 2. Clean it up, multiply both sides by x squared plus x plus 1 over x times x is x squared. 1 over x times x is 1, and then 2x. Okay. So x squared plus x plus 1 over x squared plus 2x plus 1. You can write that as x plus 1 squared. Domain is all real numbers except for 0, which is not allowed here, and -1, which is not allowed over here. Okay. All right, so that was a review of a lot of the sections leading up to the Chapter 1 exam.